All right. We've been talking about correlation and a lot of linear correlation, and today we're going to get much more into finding, and we've been talking a lot about linear. We're going to try and find what does that linear correlation look like, or can we find the equation of that line? And so what we're going to do is start taking some notes on actually finding that line. All right, so we had a little pause there. That'll be fine. So again, we're going to try and actually find that line now. Okay, where does it go? And what we're really going to do, and I'll just give you the equations, and maybe I'll see if you can kind of figure out what's actually happening. And if you can do that, that'd be very impressive. Okay, so our equation is actually going to be in slope-intercept form. It's kind of what it's going to look like. Wow, it's having trouble deleting. Oh, there we go. So y hat, that shouldn't be a big surprise, right? Because p hat, remember that was just kind of an approximation, right, or an estimate, right? And then b sub o plus b sub 1 x. And I took this one actually right from the AP sheet. Okay, instead of using the textbook's version, I took it right from this one. So based on our knowledge of slope-intercept form, what do you think b sub o is? Like in our terms that we've used before, the y-intercept. And b1 is slope, right? Because it's y equals mx plus b. They just kind of moved it around a little bit, right? And so b1 is actually going to be our slope, and that's probably one of the more complicated formulas. And we are going to actually do it by hand because I'm not sure how you're going to get information on the AP, and I'll make that a little bit bigger. Be very careful on your numerator. It is the summation of those two multiplied, not just the summation of each one and then multiplied. You have to be very careful how you write that. And then on the bottom, it is the, wish I could get that out of there. There we go. The summation of the x minus x bar squared. And that's one of them. I'm going to see if you can give me some just general words as to what's going on there. You know, you don't have to give me the whole gist of it, but we'll see if you can come up with that. And then they're saying, well, if we've got the slope, there's only one more thing I got to find then, right? And that is what? The y-intercept. And so the y-intercept, they kind of manipulate that first equation a little bit, but they put the y bar in there. But you can see how it is just a manipulation of kind of that first equation up there. And this should say B1. Sorry, that's a typo. B1. Oh, wow. Right around on top of the B. Mm-hmm. So just in general, if you were given a problem and given a bunch of data, and you had to figure out what would be the smartest thing to solve for first, I would say B1, because you need B1 to get B sub 0, correct? And maybe just overall, the very first thing to calculate would be x bar and y bar because you need that. Agreed? And what is x bar then? What does that stand for? Mean of the x values. What's y bar mean? Mean of the y values. Okay. So can anybody give me a good gist of what B1 is having me do there? What's x of I then? What's that standing for? Just take one of your data points and find out how far it is from the mean. Okay, so that's what you do for x. Then you do the same thing for that same pair. You'd find out how far it is from the y value, and then multiply those two together. And then on the bottom, you find out how far that x value is, and you square. Okay, and we'll take a look at kind of what that would look like graphically in a little bit. Okay, and we'll do this one by hand, but I kind of look at it this way. Maybe we'll just do it right now. If you had something like this, right? The mean of the x values would appear to be somewhere in here, give or take, right? Mean of the y values is somewhere in there. You see how that kind of creates a new xy coordinate? And what you would do is for your x values, if this was the mean of the x values was this one, right? This is, I know it's weird that it's going the other way. You get that? That x bar would be there though, mean of the x values, right? And the mean of the y values is here. This distance is what you're calculating right there. But you have to do that for every single point. And then this distance is, yeah, but again, you have to do that for every single point. So you can see why we would like to use technology in this. Because could this be done by hand? Yes. Okay. But notice, how do I want to say it? For example, let's just do this point. Let's say that was point 1 comma, I don't know, 5 or something like that. Okay. And then we know that the x bar, let's say x bar is actually like 4. When I actually do it, it would be 1 minus 4, correct? Which would be a negative value. Are you with me on that? And then here, if I do the y values, let's say the y bar is, well, it's bigger than 5, right? So let's say it's 6. And if you actually did the calculation, it'd be 5 minus 6, so that would also be a negative. Look at what quadrant that's in. If we kind of count this as my new xy axis, it's in the third quadrant, which is negative and negative, correct? But when you take a negative times a negative, you get positive. So if I get a bunch of stuff down here and a bunch of stuff up here, what can you tell me about those values? It's positive and positive, correct? So do you see, if I have a bunch down here and a bunch up there, how the top of this fraction will be positive and the bottom will be positive because I'm squaring it, right? So do you see how that leads to a positive slope? What if I've got a bunch of information up here and a bunch down here? I'm going to have a positive times a negative on the top, right? And that's going to give me a negative on the top, and I'm going to get a what on the bottom? Positive no matter what, right? So do you see how that would give me that negative slope? Okay, so think of it as almost creating a whole new xy axis. Okay, it's really how I kind of look at it. And so then it makes sense. And then if it's all over the place, you've got some creating a negative, you've got some creating a positive, right? And then you don't end up with a very good slope on that, right? So, well, this is going to get a little tricky, but we can do it. We're actually going to do it, like I said, by a little bit by hand. But we'll let the lists help us out a little bit. Because I think we could all actually do this physically by hand, but it would be a lot of time. Okay? So, here, oh, there's some data that looks relatively familiar. So I know most of you probably still have that somewhere, or maybe not. But it doesn't take too long to enter it. Maybe I should have told you to keep it in your calculator and use the other lists for other stuff. Go ahead and enter that in. And then, yes, I will show you how to do it much quicker. And then you'll be very mad at me. But that'll be fine. I can handle it. So I think this helps you understand a little bit more of what's going on. It is kind of a pain, I'll be honest. Wow, you guys are really fast at entering numbers. Wow. Yeah. Takes me forever. Well, that's up here, though. So, all right. So remember, this is advertising and sales, right? And we found out before that this was a pretty strong, I think, right? Positive correlation, right? But keep in mind, after a while, it is going to level off, right? Because there's only so far you can go with that. Now, obviously, if you're looking at this, and my hope, and I think what I'm going to do next year is I'm going to give them the table, but I'm not going to put what the headings of the table will be, because you need to be able to look here and find out, well, what do I need? What do I need to go find? Okay. This means take your entry and subtract the mean of the x values, right? Which is kind of these distances here, right? And then you need to find, you take each y entry and subtract it from the mean. So what are probably two pretty important things to find first? Yeah, x bar and y bar, right? There's lots of ways of doing it, okay? And so do you happen to remember any of the ways of calculating? It's really just the mean, right? I got to get back to my calculator here. We've got all of them. At least I'm pretty sure I put them back in. Yep, there they are, right? I've got list 1 and list 2, right? All the information's in there. So list 1 is my x, or explanatory, right? And list 2 is my response. Do you remember any ways of going about finding the mean of that? There's several ways the calculator will do it. You could by hand do 2.4 plus 1.6. You could do that, right? Anybody remember a quicker way? Okay, you could do the one variable statistics. Where is that? So we'll go under stat. And then what? Calculate one variable stat, right? Because we're just looking at the x value right now, right? I'm not trying to compare x and y right now. I just need x bar, right? So I just am looking for one variable. And then what? List 1. Yep, that'll do it. And in fact, that'll give you a lot of information about list 1, correct? Now, there's X bar, 1.975, so we probably should write that down somewhere. It gives me the sum, right? It gives me the sum squared. It gives me the standard deviation if it's a sample, the standard deviation if it's a population, so forth and so on, right? I think it even gives you the quartiles, doesn't it? Yep, there's your quartiles, median, max, all that good stuff, right? Okay. There is another way if you want to, and I can't even get this to clear. Oh, there we go. You could go, what's that? No, actually, it's just under list. Because under list gives you lots of operations. You go to math and then just do the mean of list 1, right? So you go to 3 and do the mean of list 1. But I kind of like the one variable statistics because it does give you a lot more information, right? You get a lot more out of it, and it might be more helpful. Okay. So either way, now we know X bar is 1.95, and so I'll just do this way for the other one, seeing them right here. For list 2. Boy, does that seem right? 204.25, that's so much bigger than the other one. But the response was quite a bit different in every case, right? So that does make sense. So what does that represent then in our calculation? I just typed a bunch of yeah, it's Y bar, very good. I just typed a bunch of keys, and we got to remember, whoa, that's terrible. We got to remember what that means. So what is it, 204.25? All right. One way that I believe you can be a little sneaky is you can store these numbers if you want, and that speeds things up for you. Okay, like store it as a letter. Okay, but that's only if you really want to do that. Let's see if let's just store this. Let's see. I'm just going to see if it's going to work. I don't know if it will. Ooh. Well, that didn't work very well, so. Oh, I hit second. You're right. We'll store that as B. And we'll store that as A. A. There we go. All right, so X bar is A. We're just going to see if this works. I'm thinking ahead. So if you didn't store them, it's okay. Just remember the numbers. So now let's go back to what we're doing. So we did that. Doing good. Now what? Well, according to this, I had to do X minus X bar. Again, is this something I could sit there and do by hand? You would basically take 2.4, you see right here, and subtract 1.97, right? And then there's your Y bar. And we can do that in Y bar. The reason I did it in 2 separate steps is because in your lists, you can just do this, right? Now, if you're really good at your calculator, you can go right to this next column, which is basically multiplying the 2 together. Why would I multiply the 2 together, though? What's the point of doing that? Because here it says I have to multiply them and then add them up, right? You see that? So again, it's almost more knowing, okay, what's it asking? How am I going to do that on my calculator, right? So let's go ahead. We have to do each entry minus the X bar, and then each entry minus the Y bar, and then multiply them together. All right, well, let's go to our calculator. Well, where am I going to do that? Go back to, there was a quickest place. Go back to list, right? That's the quickest place. So hit stat. Let's edit these things. So list 3, you go up there and you tell it what to do for list 3. And what do I really want to do? I want to take every entry from list 1 and subtract the 1.975, right? So you can go ahead and do list 1 and then do minus 1.975, right? But I'm going to try something else. Let's see if this works. I'm going to do minus, oh, I'm really having difficulty hitting the buttons today. Minus A. See if it works. Might not, right? And then I can just come back and enter the number. But there it is. That worked out pretty nice. So what do these numbers mean, right? This means how far, sorry for the pun there with the means. This is how far that is from the actual mean. So it's 2.4, a little higher than the 1.975? Yeah, by about 0.425, right? So that's where they all are. So some are a little above, some are a little bit less. But remember, do I necessarily care if these are negative or positive right now? No, it's what happens once I multiply it by the y. It really is the key, right? So let's go over. And let's do this one. And what do we want to do here? Well, I want to do the same thing with the y values. Well, my y values are in L2, right? And then minus. Again, you could put 204.25. Or for me, I'm just going to go and do B, right? And there it is. Is there any surprise that these are quite a bit larger than? No, because these were big to start with, right? And so there's no big surprise. And so we take a look here. Look at list 3 and list 4. I got a positive times a positive. Negative times negative, positive, 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 negative, negative. Well, I only have really one here so far that I see but look at how small that is. It's a 0.025 times that negative, right? You see what I mean? Oh, there's a lot of positives as a result here, correct? And so my numerator is going to be a lot of positives. And my denominator for sure is positive. Okay, so now what? Now, according to my formula, I've got to take, so basically what I have right now is this is what, list 3, right? This is list 4. Wow, that's terrible. I can't type buttons or draw today, apparently. That's list 4. Should I sum them separately and then multiply them together? No, multiply them, then sum them, correct? Again, by hand, we'd still probably be on the second column, right? And this is speeding things up just a little bit. And again, you're going to be mad at me in about 10 minutes when I show you how to do it in about 30 seconds. All right, so let's take L3 times L4 then. So this is L3 times L4. That should work. Let's find out. I didn't actually hit, I think I hit times, it didn't show up. Or I missed it, one of the two. Let's find out if this works. Sometimes it's fun to experiment. That appears to be right, doesn't it? Because we did say there would be going to be a lot of positives. Now, do you notice how that small, this 0.025 down at the bottom, how it created a very small negative? So overall, that's really not affecting me all that much, right? Especially once I turn around and sum these. You see what little effect that's going to have, right? But then the rest of them are pretty big positives, right? Look at that 22.3. I mean, that's pretty big. Okay, so now what are we going to do? Well, now that we've got, basically, if we could sum that, we've got our numerator, right? You with me on that? Well, let's figure out what that is then. How do we sum that thing? Yeah, we better get out of there because I think the other day I stayed in here and I tried to put it down at the bottom, right? That was bad. So let's quit out of there. Yeah, probably go to list is probably your best place, right? Because I'm going to do some kind of operation on the list. Go to math, very good. Sum, so, or go down to 5, right? Or hit 5. Now we have to remember which one that was, though. L5, okay. That's when you'd have to go back in if you forgot, right? You'd be like, oh man, I did all this stuff and I go back in. Are we expecting this to be a pretty big number? Yeah, it depends on what you consider big, very true. But as far as the numbers we've been seeing in our tables, it's going to be a little bit, it's kind of a little bit bigger than I would expect. But okay, 62.65. Okay, now what is that? That's my numerator, right? All right, so let's write that down somewhere. That 62.25 is my numerator. So, in other words, this is 60. I'm just going to write it here. 0.25 is my numerator. Okay. So we know that we definitely have a positive relationship going on here because the bottom's going to be positive. Okay. Now let's think about that though. In our problem, our x values were pretty tiny, weren't they? Okay, I'm going to turn around and square them and then add them up. But that's still really not going to be all that big, is it necessarily? But we do know one thing for sure. That this bottom, well, maybe I better not say that. I won't say that. We'll talk about that later. Well, let's go to that. What do we got to do? We got to do the x. Well, didn't we do x entries minus x? Well, we already did that. Where is that? That's list 3, isn't it? See right here, it's list 3. So what we have to do is take list 3, square it. Do you see all the difference there? Do I do list 3, square it, then add it? Or do I add it, then square it? How can you tell the difference? It's by the parentheses, right? Where they are. So you really hope that I didn't mess up the parentheses, right? Because if I did, we're going to do it wrong, right? But no, this is right. So take list 3, we got to square it, and then sum it. Okay. So let's go back in there. Or we can do it by hand if you want. No? Okay. Well, let's go back in here then. And all right, let's go over and do this one then. So where was that again? You said list 3? So let's take list 3. I always look up there for some reason, and I don't think I hit things. Okay. And square it. That looks weird, but it's going to work, right? What's this 6.3e negative 4 thing there? Yeah, that's scientific notation, right? So that means times 10 to the negative 4, so that's 0.000. So that's really tiny, right? So now what? Let's add those up. Again, don't forget to quit, which is I did the other day. And where do we go again? Yeah, list. I'm going to do something with the list, right? And I think you guys told me math, right? And sum. And then we got list 6 this time. Yeah, it helps to remember which one you're on. 1.235. What's that number though? Could that be a correlation coefficient? No, it can't be, right? That's not what that stands for. That's just my change in explicitly squared, if you think of it that way. All right, so it's 1.235. All right, where does that go? That goes here. 1.235. Are you with me on that? So if I take that math right there, that gives me what? What is that going to represent? Which is what? Yeah, the slope, right? It's basically the slope of my regression line. Think of the regression line as the best fit line. I know you've heard that word before, but when we did it in Algebra 2, we kind of cheated a little bit. We just picked a couple points and found a line. Here, you are finding the very best line you could put in there, okay? And so what do we get for a value on that? I don't think it's very pretty, is it? Yeah, we're going to have to probably go out a little bit, aren't we? 50.73, is that what you got? Did I write a number down wrong up here, though? Is it 62.25 or 62.65? Yeah, I wrote the number down. Yeah. And 62.65 was what was in my notes. I'm like, well, one of them's got to be wrong, right? I just, a little flipping of numbers around there, I think. That's my fault. 62.65 over 1. And what'd you get, 50 point something? 7, like what would we, I don't, yeah, how far should we go here? I don't know. Yeah, 0.73, okay. So that's B1. Okay. So that's kind of our slope of our line. All right, so we're doing pretty good. Well, now what? Well, that's not a line yet. That's just the tilt. Oh, yeah, we got to find the, what's that stand for again? The B sub O? That stands for, yeah, okay, how are we going to do that? Well, we have almost all the math here, don't we? We need to find B sub O. Do we know Y bar? Yeah, that's 204.25, right? Minus this number. And that might be where you would want to, if you're taking a really big test, you would store this really horrible decimal for B1 as something, and then you can put it in here and do the math with it, right? You know what I mean? That's where that storing really comes in handy, right? Times X bar, which was 1.975. So you see, that's actually pretty clever. And do you see how they are relating it back to X bar and Y bar? So you're kind of creating that new, actually kind of like I was showing you before, right? And so, well, there you go. We just got to do that calculation, and we've got it. And I think I took the decimal out a little further, but I don't think it's going to change our y-intercept all that much. Because let's face it, this is about 50 times 2 over here, so that's about 100, right? So this should be around 104 somewhere probably, right? Okay, so you got 104.06, and that's approximate, right? And this is also approximate. We should probably be careful in our notation. So now what? Yeah, just basically, and you know what, I'll be honest, I don't care if you put how you put that down, as long as it's in a form that somebody could graph, but apparently this is the way that the AP likes to see it. So y hat, wow, that's a terrible hat, but anyways, y hat is 104.06 plus 50.73 x. They're saying that the data we have is best represented by that line. Now, does that mean that it's good correlation? No. That's where the correlation coefficient comes in, which we found out to be like 0.91 or something like that for this, though, didn't we? So it's pretty good. So is there any surprise that we had a positive slope? No. Okay. Now, does the slope itself matter? Well, not really. It could have a positive 2 slope. It's still going to be a positive correlation, correct? But the more the correlation, in this case, that greater slope means I'm getting a pretty good return on my investment. Right? If you look at it that way, in the context of this problem. So now, the reason you would use this is now I can predict things. I could say, what would happen if I spent this much? What would happen if I spent this much? Right? Because that would be the explanatory, and then the response would come out. But remember, there is going to be a limit here. So is this overall going to be the best representation? Well, there's some limits to how far it's going to be good. Right? So you have to be very careful. And so really what we found, if we go back to this first, and it really kind of boils back to calculus. I hate to keep bringing that up, but there's your, let's say there's your X bar and your Y bar, right? And I have all this data all over the place. What we found is a line I could throw through there that minimizes all of this stuff. All these what are called, these are called residuals. That's what they're called. Because it's not perfect, right? It's not on the line. All these extra distances, difference in X and the difference in the Y, are called residuals. I minimized the residuals. I basically found a line that made that as small as possible. So it's not that line, it's this line, it's not that one. It's not that one. It's that one I found makes that overall number as small as it could. So do you see how if I had a point over here, how that could change my line a little bit? Or a point down here? Changes where my line would go because I'm still trying to minimize that residual. Okay. Questions? All right, so now you've anticipated this, right? You've been like, okay, Mr. Bokless, we've done all your by hand stuff. In fact, you've already done this. Use technology to find the regression. Well, we kind of did a little bit. We cheated, right? But who wants to do all that by hand? I don't. All right. Any ideas how we might do that by hand? Or by a calculator? Yeah, you've already done it. When we found correlation coefficient, we cheated. We already found the regression line. So how do we do that? Where do we go? You say stat, I heard somebody say? Yeah, look at the fourth one. Oh, yeah. Now what? What do we got to tell it, though? Yeah, I got to tell it the explanatory and the response, right? I got to tell it, well, which ones am I finding a line for, right? But remember, how do we tell it that I've given it the first thing? Yeah, comma, and then this too. And then remember, they do give you the option of giving another list that tells you how frequently to use each one. But we're just using each one once, so we don't have to put anything in. So that's though when you have a histogram or something, that could be really helpful, right? All right, so let's go ahead. We got a whole lot more information before. Why is that? Yeah, we had diagnostics on, right? Mine didn't, but I don't know if some do, some don't. I would assume that it stayed on. I'm not sure why mine would not have, because I did turn it on. So I don't remember turning it off. I could have. Again, that just tells you R and R squared, right, as the other things you get. R being the correlation coefficient, which was what again for this one? Like 0.912. That's pretty good, right? And it's a very positive, very strong. And look at these numbers. Those look really, really familiar. How about that? Bless you. It took a lot less time, huh? Yeah. But if I just show you this, you're not going to understand the whole. What you're really finding is trying to minimize that residual. You go, oh yeah, that's a good line. All right. No idea why that worked. Okay. Are you good? Yeah. So that's how you find the best fit line. So what do you think if the data was all over the place? Would my calculator still give me a best fit line? Would it still go and would it still do the work? Would it give me a best fit line? It would give me a linear regression, correct? What would be very different? It would still give me a slope. It would still get me B1. It would still get me B sub 0. It would still do all of that. What would be a huge difference between, say, the one we did and if we did that one that I just made up there in the black? What would be one of your biggest differences? Obviously, the slope would be different. The y-intercept would be different. But it would still find a line. It would still find one. What would you say your correlation coefficient would be, approximately, for that one? Yeah, it would probably go positive, just based on what I see. But it might even put the best fit line, kind of, because it's going to minimize all of this extra stuff, right? If it puts x bar and y bar, and then it'd minimize all that stuff. But your correlation coefficient would be really bad. And so if you get something like this, you would say it's a very weak linear correlation because it's curved, right? But it would still give you a line. It just wouldn't be a very good representation of the data. So you have to be careful.